Hey guys! Alright, today we're going to do section 4 of chapter 8, which is radical notation with nth roots. So this section is actually pretty simple because we already talked about exponent rules, and basically we're just doing the same exact thing that we were doing in chapter 7 where we're talking about rational exponents, except this time instead of using the exponent form, now we're going to be using the radical form. So it's the same exact thing, the only difference is that we're writing it differently. Okay, so the first thing that we want to talk about is that when you have an n value greater than or equal to 2, I know that the nth root of x is equal to x to the 1 over n. So remember that an nth root is just a fraction power. Okay, so if you have a power of x to the 1/2, that's the same thing as the square root of x. Or if you have a power of x to the 1/4, that's the same thing as the 4th root of x. So we can go back and forth between exponential and radical form. Alright, our root of a power theorem says that for m greater than or equal to 1 and n greater than or equal to 2 and x greater than or equal to 0, meaning that we have to have a positive number as our base, okay, I can say that the nth root of x to the m is the same thing as the nth root of x to the m, so I'm using that power to a power rule, which is x to the m over n. So if you have that power that is a fraction, remember that whatever's in the numerator is what you're raising it to, and whatever's in the denominator, that's the root that you're taking it to. Alright, so let's do some examples where we simplify some stuff. So if I have my 4th root of x to the 8th, that's going to be x to the 8 over 4, right, if I just change it into my notation here, which simplifies down to x squared. Okay, easy peasy. Over here, if I have the 3rd root of y to the 18th, I can rewrite that as y to the 18 over 3. Remember that my numerator is the power that I'm taking it to, and my denominator is the root that I'm taking it to. So if I simplify that, 18 over 3, that's just 6. So this is going to be y to the 6th. Alright. Down here, I've got the square root of the square root of the square root of x. Okay, so that looks kind of tricky, but if I just rewrite that with exponent rules, I know that I can rewrite that as x to the 1/2 to the 1/2 to the 1/2. Okay? Now I can use my power to a power rule in order to figure out how to simplify that down. Remember that power to a power is when you multiply. So if I use the power to a power here, I have x to the 1/4, that's me combining these two, then that's to the 1/2. And then if I do it again, 1/4 times 1/2, that's just going to be x to the 1/8. So that's the same thing as the 8th root of x. Okay, this next one here, this is the square root of x to the 1/2. Well, I know that I can rewrite that as x to the 1/2 to the 1/2 because 1/2 is square root. So then I can use my power to a power rule to simplify that down. I multiply those two together and I get x to the 1/4. In other words, this is the same thing as the 4th root of x. Alright, moving on. Here I've got the square root of x over the square root of the square root of x. So again, I'm going to start by just simplifying the top and bottom here. So on top, this is x to the 1/2. On the bottom, this is x to the 1/2 to the 1/2. Okay, if I'm taking the square root of the square root, it's the same thing as power to a power. So down here, I'll have x to the 1/2 over x to the 1/4. And remember that using my exponent rules, if I have a power over another power, I can subtract those exponents. So this would be the same thing as 1/4 minus 1/2. Okay, remember that 1/2, that's the same thing as 2/4. So if I take 2/4 minus 1/4, I'll get 1/4, and this will just be x to the 1/4. Alright, these ones are a little bit trickier because now I'm talking about cube roots. So if I rewrite this, this is going to be 512 to the cube root, which is to the 1/3, to the cube root again, which is 1/3. So if I rewrite that, that's going to be 512 to to the 1/9. If I just plug that into my calculator, (512 to the 1/9) gives me 2. Alright, moving on. Over here, I've got the 6th root of 64/729. So remember that I can rewrite this as 64/729 to the 1/6, and I can split that up into 64 to the 1/6 over 729 to the 1/6. Okay, if I plug each of those into my calculator, 64 to the 1/6 gives me 2, and 729 to the 1/6 gives me 3. So this is just 2/3. Alright, next up I've got the 6th root of y to the 4th. So again, I can rewrite that as y to the 4th over, sorry about that. I can rewrite that as y to the 4/6. Okay, I can simplify that down. I know that 4/6 simplifies down to 2/3, so this is just y to the 2/3. Or you can rewrite that as the cube root of y squared. Okay, so this one we couldn't actually simplify down to something quite as nice, but we can just leave it like this. Or you can leave it in radical form, which is fine also. I don't remember right off the top of my head if the answers in the back of the book put it in radical form or if they put it in exponent form, but I personally think that exponent form is a lot easier, so unless they specifically tell you to put it in radical form, I would probably just leave it in exponential form if I were you. Alright, that's everything for section 4.